Okay friends, welcome back. Let's say in the previous session we have seen even signal, odd signal and neither even nor odd signal. So if a signal is neither even nor odd signal, we can represent or we can divide the signal into two forms. One is a even part and another one is a odd part. This is what we have seen. And we have seen u of t, which is nothing but a neither even nor odd. In that, even part is nothing but half and odd part is nothing but half signum t. Okay, we have seen these things. Let's see one more example so that how we can do this. So let's say this is x of t is given. Okay, you tell me what kind of signal it is. Is it an even signal? Answer is no. Is it an odd signal? Answer is no. Because there is nothing in the negative portion to compare with. So we don't have anything to compare with in the negative portion. So we can decide that it is a neither even nor odd signal. So whenever the signal is neither even nor odd, then we can represent that into two forms. One is a even part, another one is odd part. So let's see how we can calculate even part or odd part. So to find out even part or odd part, first we require x of minus t. X of minus t. X of minus t means we have to fold the signal. We have to fold the signal. If I fold the signal, then it will go to minus 5, minus 3. Minus 5, minus 3, 2. Then I want to find out even part, x even part of t. That means x of t plus x of minus t by 2. That means we have to add these two waveforms and divide it by 2. For a negative portion, 0 between minus 3 and minus 5, we are having 2. So 2 plus 0, 2 by 2, that is 1. So the even part is whose value is 1. Next, 2 plus 0, again 2 by 2, that is again 1. This is what the even part. Suppose if I try to calculate odd part, that is x of t minus x of minus t divided by 2. Next, 0 minus 2, minus 2 by 2, that is minus 1. Minus 1, 3, minus 3, minus 5. Next, 2 minus 0, 2 by 2, that is 1. So this is what the odd part. If I add them, can I get the original signal? Even part, odd part. 1 minus 1, that is going to be 0, and 1 plus 1, that is going to be 2. Yes, if I add them, we can get the original signal. So this is the way we can calculate even part and odd part if waveforms are given. So whatever you want to find out, it doesn't matter. First you have to calculate x of minus t. Okay. Next, one more example. Let's say a discrete time signal is given like this. X of n is equal to 2, let's say 4, 1, minus 3. Arrow is given here. Is it an even signal? No. Is it an odd signal? No. It is also neither even nor odd signal in the discrete time case. Because if you fold it, you are not going to get the same signal, or you are not going to get the minus of the given signal. So it is a neither even nor odd signal. So to calculate even part and odd part, first we have to calculate x of minus n. So remember, whenever you try to calculate x of minus n, just we have to write in the reverse order. But please match the 0 positions. So in the reverse order means minus 3, 1, 4, 2. So this position matching is very, very important, because while we are adding, we have to know 2 has to be added with 0, 4 has to be added with minus 3, 1, 1, minus 3, like that it has to be added. So then first I am calculating even part, x even part of n, that is x of n plus x of minus n divided by 2. If I add them, 2 plus 0, 2 by 2, 1, 4 minus 3, 1 by 2, 1 plus 1, 1, minus, so it is going to be 1 by 2, 1 by 2, 1. So this is what the even part. Of course, it is an even signal. Why? 1 by 2, 1 by 2, 1, 1 matching. So they are nothing but the even signal. Suppose if I try to calculate odd signal, odd part, x of n minus x of minus n divided by 2. Subtraction. 2 minus 0, 2 by 2, 1. 4 minus of minus 3, that is nothing but 8. 8 by 2, that is 4. Second, sorry, 7 by 2. 4 plus 3, that is 7 by 2. Next 0. Next minus 7 by 2, minus 1. This is what the odd signal. So if you observe carefully, at n is equal to 0, its value has to be 0. Minus 7 by 2 plus 7 by 2, minus 1 plus 1. So whatever there for the positive values of n, there is for the negative values of n also, but only with the sign changes. Okay. So I can say this is an odd signal, this is an even signal. If I add these two parts, can I get the original signal? Yes. 1 plus 1, 2. 1 by 2 plus 7 by 2, 8 by 2, that is nothing but 4. 1 plus 0, 1. Again it is 1 by 2 minus 7 by 2, that is nothing but how much? Yeah, minus 6 by 2, that is nothing but minus 3. Again if I add them, we are going to get 0. So this is the way we can calculate even part and odd part, but be careful. First match the 0 positions. Okay, take it. Let's see first addition properties. In the addition properties, suppose if a even signal added with even signal, what is the result we are going to get? To check this, just we have to understand, if even signal, in that t is replaced with minus t, again the same thing. T is replaced with minus t, again the same thing, because they are the even signal. So overall, if t is replaced with minus t, we are going to get the same signal, which is nothing but even signal. So addition of two even signals is an even signal. Next, odd signal plus odd signal. So many people say even signal, but that's not the correct, because whatever you said which is related to multiplication properties, but I am talking about addition properties. So let's see again. T is replaced with minus t, then what will happen to whole thing? T is replaced with minus t in the odd signal, then minus sign we will get. T is replaced with minus t, again minus sign. So if you take minus common out, so it is nothing but whole minus. So which is nothing but odd signal. So T is replaced with minus t, we are going to get odd signal. Next, one even signal added with the odd signal. Here also so many people will say odd signal. No, that's not correct. Because see, it is something like even part plus odd part. Which signal can be represented in the form of even part and odd part? Which is neither even nor odd. Neither even nor odd. Okay. Next, addition of DC. Let's say one even signal added with DC. Let's say some K. Remember, DC signal is also even signal. DC signal is always a even signal. Why? If you fold it, you are going to get the same signal. So that means it is similar to this property, even signal plus even signal, again a even signal. Next, odd signal plus DC. It is something similar to this property. Why? Even signal plus odd signal. So because it is an even signal, this is an odd signal. So it is going to be neither even nor odd. Understood? So this is the addition of DC. This is the addition properties. Next, multiplication properties. This is everybody knows it. A even signal multiplied with even signal, again even signal. Odd signal multiplied with odd signal, again a even signal. Even signal multiplied with odd signal, which is odd signal. So these are the properties. Remaining properties we will see. First take down this property. Differentiation property. What is the differentiation property saying? That suppose if you differentiate a even signal, what is the result we are going to get? If you differentiate a odd signal, then what we are going to get? So for that, just assume even signal means cos t and odd signal means sin t. Differentiation of cos t is a sin t, which is nothing but odd signal. Differentiation of sin t is a differentiation of sin t, which is nothing but cos t, which is nothing but even signal. So here we can say simply it is a odd signal and it is a even signal. This is very, very important. Based on this, so many problems were asked. Differentiation of even signal is a odd signal. Differentiation of odd signal will become a even signal. Okay. Next, integration over symmetrical limits. Next property. Integration over symmetrical limits. Over symmetrical limits. Let's see first property in that. Suppose if I take integral minus a to a, these are nothing but integration over symmetrical limits, means lower limit upper limit has to be same with a different sign. Okay. If you take a odd signal, integration of odd signal over symmetrical limits, what will happen? So let's check it out. Let's take one example so that you can understand easily. let's say odd signal. Okay. If you take the integration, that means we are calculating the area under the curve between minus a to plus a. So we have to add this area with this area. If you observe carefully, the area what we are going to get is a positive value here. The area what we are going to get is a negative value here. So a into minus 1 minus a into 1, that is nothing but a. So this is a, this is minus a. If you add them, what we are going to get? 0. So remember, whenever you integrate a odd signal over a symmetrical limit, always the result is 0. I can extend this to integral minus infinity to infinity x odd part dt. So it is also symmetrical limits, it is also going to give you 0. Okay, so symmetrical limits means maybe a constant values or maybe minus infinity to plus infinity. In the similar manner, if you take minus a to a even signal, if you integrate an even signal over symmetrical limits, what will happen? Again, I am taking a even signal example, which is like this. So here also integration means we have to calculate the area under the curve. So whatever the area we are having in this minus a to a, the same area will be there. So what the integration theorem is saying that instead of finding out total area, just to find this part and double it. Just to find this part of area and multiply with 2, you are going to get the total area. So that means instead of finding area between minus a to a, what I do actually, I will take the limits from 0 to a, find the area, double it, we are going to get the total area. That means we are going to get 2 multiplied with 0 to a even signal. Or we can take a minus a to 0 also, it won't make any difference, both are same. So I can extend this to minus infinity to plus infinity even part dt, which is 2 into integral 0 to infinity dt. That's what we are going to get. Okay, take it. We have to go with the summation over symmetrical limits. Summation over symmetrical limits. How we can do this? Let's say summation n is equal to minus n to capital N. If you take odd part, then it is 0. How, sir? Simply let's say take one odd signal. At 0 its value is 0. Let's say 1 1. Let's say at 2 its value is 2. Odd signal, so at minus 1 it has to be minus 1, at minus 2 it has to be minus 2. If we add them, minus 2 plus 2 get cancelled, minus 1 plus 1 get cancelled, finally we are going to get 0. So this is what odd signal. We can extend this to infinity also. Summation n is equal to minus infinity to infinity x odd part of n is equal to 0. Next, summation n is equal to minus n to n x even part of n. Let's take some examples. So this is a even signal. Actually, in the integration what we have done, whatever the area we are having, we have to double it. But here we have one problem. What is that problem, sir? See, 2 is repeating twice, 1 is also repeating, but whereas 3 is not repeating. So if you take 0 to 2 twice it, 3 will come twice. So that is going to give you a wrong answer. So to avoid that, what we will write is, first we will take this 0 will be outside, then we will take 2 into summation n is equal to 1 to n x even part n, like that. So we can extend this to infinity also. N is equal to minus infinity to infinity x even part, because 0 is not repeating, so we are taking 0 outside. 2 into summation n is equal to 1 to infinity x even. Okay, take it. Okay. Till now we have seen even, that is symmetry, odd, that is antisymmetry, neither even nor odd, which is unsymmetry, for a real signals. What if the signal is a complex signal? Then how can we see this symmetry, antisymmetry and unsymmetry for a complex signal? Okay. So for complex signals, suppose if you take a signal x of minus t along with conjugate also, if you get the same signal x of t for a discrete time case also, x conjugate of minus n is equal to x of n. If this condition is satisfied, then we can call the complex signal as a even signal, complex even signal, but that is not the word usually used. Then what is the word they are using? So for layman terms, it is a complex even signal. This is the word actually we have to, we can without much confusion we can use it, but in the textbooks or in the examinations they will give you this word conjugate symmetry. Conjugate symmetry. This is the word they will give. Conjugate symmetry. In the similar manner, x conjugate of minus t is equal to minus x of t. X conjugate of minus n minus x of n. Then we can call the signal is a complex odd signal or conjugate antisymmetric signal. Complex odd or conjugate antisymmetric. Suppose if neither of them, x conjugate of minus t is not equal to x of t, is not equal to minus x of t. X, let's say conjugate of minus n is not equal to x of n, is not equal to minus x of n. If both are not possible, then we can call neither even nor odd signal or conjugate unsymmetric. Conjugate unsymmetric. Okay, take it. I will take 4 examples, let's say. Don't write, first listen carefully. Example 1, x of t is equal to e power gt. e power gt. Example 2. X of t is equal to t e power gt. Example 3. X of t is equal to cos t plus j t square. T cube plus j sin t. Let's take these examples. Okay, listen carefully. Suppose x conjugate of minus t we have to check. First take x of minus t, then we will take conjugate. X of minus t means wherever t is there, that has to be replaced with minus t. That means e power minus jt whole conjugate. What it is going to give you? Conjugate means wherever j is there, that has to be replaced with minus j. So if j is replaced with minus j, minus minus get cancelled, finally e power j t, which is nothing but x of t. So x conjugate of minus t is going to give you x of t. What kind of signal it is? Conjugate, symmetric. It is a conjugate symmetric signal. But here I want to say some more things. Let's see. I can write x of t e power jt, which is in the Euler expansion cos t plus j sin t. Cos t plus j sin t. In this, can you tell me what is the real part of x of t? Individually, which is cos t. Can you tell me about cos t? Is it an even function or odd function? Which is nothing but a even function. Next, what is imaginary part of x of t? Which is sin t. Individually, sin t is a odd function. Individually, sin t is a odd function. Next, coming to this one. X conjugate of minus t we have to calculate. First x of minus t, that means minus t e power minus jt whole conjugate. J has to be replaced with minus j, minus t e power jt, which is nothing but minus x of t. So if you take x conjugate of minus t, if you get minus x of t, what kind of signal it is? Conjugate antisymmetric. Antisymmetric. Here we can write x of t, which is t e power jt. E power jt we already know, cos t plus j sin t. If it is multiplied with t, t cos t plus j t sin t. J t sin t. So here you tell me, what is real part of x of t? Which is t cos t. You tell me about this function. If t is replaced with minus t, then cos minus t is cos t, but we are having minus t here. So finally this is going to be odd. This is going to be odd. Next, what is imaginary part of x of t? Which is t sin t, odd function multiplied with odd function, which is even function. Which is even function. Coming to third example, x conjugate of minus t. First t is replaced with minus t, cos t plus j t square whole conjugate, which is
cos t minus j t square. So I can say it is not equal to x of t. It is not equal to minus x of t also. So I can say it is a unsymmetric signal. Unsymmetric. If I say real part of x of t, which is cos t, so which is nothing but a even function. Imaginary part of x of t, which is t square, that is also even function. Next, x of minus t conjugate, if I try to find out, minus t cube minus j sin t whole conjugate, then it is minus t cube plus j sin t. So if you observe carefully, this is also not equal to x of t. This is not equal to minus x of t. So this is also unsymmetric signal. Unsymmetric signal. So here, what is the real part? Which is t cube. If t is replaced with minus t, this is going to be minus, so it is odd. Imaginary part of x of t, which is sin t, that is also odd. So this is what we have to see. In that, what are the important points we have to observe? So please, whenever the signal is a conjugate symmetric signal, the real part is always even, imaginary part is always odd. When the signal is conjugate anti-symmetric, the real part is always odd, imaginary part is always even. If it is a unsymmetric, then both real part and imaginary part either even, or both real part and imaginary part are odd. So both has to be odd or both has to be even, then we can say that is a unsymmetric. This is very important. So many PSUs ask this question. So in a complex signal, if real part is even, imaginary part is also even, then what kind of symmetry it exhibits? It won't exhibit any symmetry, that is unsymmetric signals. Okay, take it. Okay. Here also, suppose if the signal is neither even nor odd or unsymmetric signal, if x of t is unsymmetric, or if signal is unsymmetric, then we can write x of t is a symmetric part, that is complex even part, plus complex odd part. You know how to calculate complex even part? X of t plus x conjugate of minus t by 2. In the similar manner, x complex odd part, which is calculated by x of t minus x conjugate of minus t by 2. For a discrete time case also, x of n is equal to x complex even part of n complex odd part of n. So even part or symmetry part is nothing but x of n plus x conjugate of minus n by 2. Complex odd part x of n minus x conjugate of minus n by 2. This is the way we can calculate even part and odd part. Take it. take one question which is unsymmetric, so that we can find symmetry part and antisymmetric part. Let's say x of n is given -4 minus j5 comma 1 plus j2 comma 4. So it is unsymmetric, so that we have to calculate symmetric part and antisymmetric part. Calculate symmetric and antisymmetric part. For that, first what we have to calculate? X conjugate of minus n. Minus n means we have to write in the reverse order. Conjugate means we have to take the conjugate of each term. Reverse order. 4 comma 1 plus j2 conjugate 1 minus j2. Here is the arrow. Minus 4 plus j5. Next, complex even part, that is x of n plus x conjugate of minus n by 2. If you add them, let's say minus 4 plus 4 get cancelled, then it is minus j 2.5. These two get cancelled, 1 j 2.5. That's what the even part or symmetry part. Suppose if you try to calculate odd or antisymmetric part, then x of n minus x conjugate of minus n by 2. Subtract it. Minus 4 minus 4 minus 4 minus j 2.5 comma, these two get cancelled, j2. Next, 8 by 2, that is 4 minus j 2.5. So this is the antisymmetric part. Okay. So listen carefully. In the antisymmetric part, I told you real part is even, imaginary part is odd. Sorry, real part is odd, imaginary part is even. So in the antisymmetric, so check it out. 4 minus 4, that means real part is odd, imaginary part minus 0.25, sorry, minus 2.5 minus 2.5. So that is nothing but even part. So this is what you have to calculate. Okay, take it.